This presentation discusses the strategic and conceptual project plans for 289 Flinders Street, as narrated by Henry, Isaac, Tom, and Ned. Accor Group have purchased a block of 289 Flinders Street, located on the eastern fringe of the Adelaide CBD, and are planning to invest and develop a commercial office building. All existing buildings on site have recently been demolished and are cleared for construction. Currently, Accor Group have finalised a conceptual drawing for the construction of a two-storey commercial office building, as market trends suggest that Adelaide is shaping up as a strong avenue for commercial investment. There is a great demand for office space for commercial property within Adelaide. Vacancy rates for the prime office market in the Adelaide CBD have been on a steady downward trend since 2016. There is a feasible business case for Accor Group to develop this commercial office building and lease it to a business to generate profit. Currently, TCL Australia, an engineering company, are looking to expand into Adelaide and are very interested to lease a commercial property off Accor Group. Project requirements include a fully serviced two-storey commercial office building, a budget of $2.5 million, at least 3 sustainable attributes to be explored, up-to-date as-built information after the completion of construction, and a prefabricated HVAC system. Through the project's purpose, the project's business case, and the project's requirements, we were able to explore and create a list of project objectives. We believe that the project needs to embody and deliver on these elements and characteristics to fulfill the purpose of why Accor Group wants to develop a commercial office building in the first place. In constructions, we're able to define what the project requires and the deliverables that need to be met. This broadly outlines the scope of the project by listing each deliverable and work package with a loosely estimated expected delivery date. Then also listed what was excluded from the project scope and listed some assumptions made about the project. Both these elements can help clarify what is and isn't included in the feasibility study and help us identify any risks that the project may endure. So, for example, the project scope did not include the excavation of rock and the removal of hazardous materials, and thus the feasibility study did not take these into account. However, we did assume the coronavirus pandemic will have an impact or may have an impact on the project, such as these 3 risks, but again, the project feasibility study did not take these into account. We also identified some constraints within the project. So the first being budget. We do not want to exceed the $2.5 million that Accor Group has allowed for. Timing, we'd also like to see the project completed within 1 year of when the head contractor possesses the site. We know there's a client requirement, including prefabricated HVAC system. Another client requirement was to provide up-to-date asset information for maintenance and operation, and also the potential refurbishment in the future. And because of these 2 client requirements, we thought the project must be managed under BIM software to account for these later in the future. And for a quality standpoint, we'd like to see all building inspections pass, which will also make sure there's no impact on the program of the project. It was also important to define the critical success factors for the project. They can act as a guide and clearly set out what the project team needs to strive for to ensure a successful development. Example for one of our critical success factors are well-coordinated design and clear technical specifications. We require that because if our shop drawings are inaccurate, that's going to impact the cost of the project and also the time of the project. So these critical success factors were developed through our own brainstorming, also through previous lessons learned from similar projects. So office developments that we've previously done, we've identified any lessons learned from these projects and we're able to place them back onto the critical success factors. It's also important to identify the stakeholders that are related to the project. So we obviously have the client and the potential tenant, as well as the principal consultants will have a great impact on how the project is set and run. We also have other primary stakeholders in engineers, architects, and future unknown currently, but we know they will be there, head contractors, subcontractors, and suppliers. We also identified secondary stakeholders that will have an indirect impact on the project or will be impacted indirectly by the project. An initial high-level project planning scheme was also developed to distribute the roles and responsibilities of this upcoming presentation, including the feasibility study, the risk register, the asset management and clash detection, the contract type, the tender, and this project brief.
Utilising Rawlinson's Australian Construction Handbook Edition 34, the cost plan was developed utilising an elemental cost breakdown rather than a full composite rate. This allows for greater breakdown on industry prices. Due to the older out-of-date edition of 2016, an elemental cost per square metre rate increase of 1% each year was added to the elemental price. This was to allow for general inflation to 2021. This was a total of a 4% increase. CostX was utilised to measure the gross floor area to accurately measure the results found in an initial cost plan. With the primary budget of $2.5 million, thin constructions were required to include as-built information, prefabricated HVAC systems, and a minimum of 3 sustainable attributes, which can all be seen in the building cost of the cost plan. The building cost of the project valued at $1,936,469. The net project cost was inclusive of the sustainable attributes, inclusive of a green lobby, lighting controls, and insulation increases. Furthermore, the project cost was finalised at the budget $2.5 million, inclusive of the additional fire requirements under the NCC that were indicated through further investigation. This was inclusive of the lift and also external stairs. The COVID-19 pandemic had a considerable impact on the global market, and for the construction industry identified key elements that would affect the project. Lengthy lead times were identified for varying materials across all commercial construction projects, and the ongoing uncertainty of supply of materials will continuously add a burden to the project. Furthermore, the pandemic has also identified significant shortages in demand for office buildings themselves, as larger organisations have implemented working from home strategies to try and minimise employee exposure to the virus. However, on the contrary, as businesses begin to normalise and vaccines are rolled out, the workforce will return to normal and office space demand will again increase. Market demand has increased for sustainable attributes within the built environment. This is mainly due to climate change and the prompt from organisations to do their part. Currently, the construction industry consumes 40% of the total energy consumption worldwide. Thus, more sustainable attributes and construction methods are desirable within modern-day projects. The introduction of sustainability within office buildings is seen as desirable for tenants looking to use the space. The implementation of these elements has been identified to increase employee mental health and productivity. Lastly, the upfront cost of sustainable attributes will shortly be paid for through the reduction of running costs throughout the life cycle of the building.
A prefabricated HVAC system will be feasible, however this method will put a huge amount of pressure in adhering to the short project timeline. A prefabricated variable air volume unit has been suggested by local contractor O'Connors, who specialises in mechanical systems. This method will require an out-of-hours Flinders Street shutdown to crane the prefabricated into the building. Extensive planning will be required to ensure that the works will adhere to the project timeline. Prefabrication will be a cost-saving exercise, however this method could create delays and defects.
Prior to the commencement of any construction project, it is important to ensure that the design is suitable and buildable. To do this, Thin Constructions carried out a thorough clash detection based on the National Construction Code's Building Code of Australia and using Navisworks clash detection. The NCC assessment was based on 3 key areas, namely fire resistance, access and egress, and health and amenity. These Navisworks clashes were primarily made up of badly coordinated structural and architectural elements in the model. The final clash is that of the toilet cubicles. As shown in the provided image, there is only a space of approximately 735 mil between the toilet and the cubicle. Therefore, as per section F2.4E of the BCA in conjunction with AS 1428.1, this is below the minimum space of 900 mil. Due to the space currently between the cubicle and the wall, Expansion of this cubicle may affect the access outside of it. This will then require increasing the overall room size, which would be significant redesign and involve additional pricing. Alternatively, the toilet orientation could be changed to create more space. This clash could have substantial cost effects if not attended to prior to the construction. Carrying out this analysis was essential as it identified a number of key concerns for the project team, further confirming the need to do clash detection during the design and concept stages of all projects. Clause D 1.3b states that in any Class 5 building, every stairway or ramp serving as a required exit must be fire isolated. This means that due to the internal stair not being fire isolated, 2 additional external stairs are recommended. This will require both an architectural and structural redesign. However, will retain the internal aesthetic of the building. This redesign must consider structural elements in the facade to supply and install of 2 steel stairways and a concrete landing pad, plus of course a door, a frame and its hardware. This will have a significant cost effect, however, should not affect the overall program. As shown in the image, the balustrade on the first level is terminating directly on the aluminium window frame. As this fixing point will need to be structural to ensure the stability of the handrail, this design must be reviewed. The first and most logical option is to remove the horizontal fixing point and have only slab fixings. However, this would require an engineer's approval. Alternatively, the setup of the handrail could be adjusted to land aligned with the brickwork. This would then require some backing to ensure an adequate fixing behind the plasterboard. Neither of these options will have major cost or time consequences if resolved in the early stages of the project. The first and most costly clash is BC3. Table D 3.1 of the BCA states access must be provided to and within all areas normally used by the occupants. Therefore, considering there are facilities in the way of toilets on the upper floor, it can be assumed this is an area they would normally occupy. Furthermore, Clause D 3.3f requires a building with more than 200 square metres on each floor, requiring a lift. Therefore, it is imperative that a lift is included in this design. This will have significant time and budget effects on the project and must be investigated further.
Thin Constructions have identified 12 potential risks this project may face. This equates to approximately $700,000 of risk contingency. These risks are based on the current status of the project in its concept phase. A risk register was generated to weight the risks on their given impact. From this, the 3 highest rated risks were global supply stock volatility, an inadequate budget, and the proposed project timeline. Suggested mitigation strategies can be implemented to heavily reduce or eliminate the identified risks, including avoidance, mitigation, transfer, and acceptance. The current global COVID-19 pandemic which we're in has created many supply and freight shortages across the world. The construction industry is suffering due to the large supply chain issues which products such as timber have. COVID-19 has put considerable barriers up against international freight and imported goods within Australia. There is also a huge demand on products such as timber due to the increase in government spending through grants and home builder handouts encouraging the construction industry to operate to stimulate the economy. The global supply stock risk can be seen below, where an impact score of 9 and a probability score of 0.9 generated an overall risk score of 8.1. The current impact probability was rated at 81%, with a total risk contingency given at just over 60,000. An appropriate risk response strategy was research prior to design consultant selections to ensure the product is available and the price is not volatile. Accord Group's budget is at risk as only $129,000 has been left for contingency for the project. The increase in scope through the inclusion of sustainable features and identification of missing items including the lift and fire escape stairs has taken up a lot of budget. The cost plan was also formulated using 2016 rates with 4% added to them. In 2016 there was no global pandemic, so it is likely these rates do not account for the increase in trade and product prices due to the pandemic. This is a huge risk for Accord Group who will need to seek cost-saving options throughout the building to adhere to their budget. The risk has been given a risk score of 7.4, and a risk contingency allowance of $187,000 has been allowed for by Thin Constructions. The Accord Group have proposed a 1-year project timeline for the construction of 289 Flinders Street, Adelaide. This is not an adequate timeline factoring in the budget and supply constraints which this project is facing. A 1-year timeline will force a 7-day construction program including night works, which will be costly. There are also many restraints on the project program due to the prefabrication of the HVAC system and the volatility in product supply chains due to COVID-19. The proposed project timeline risk has an impact score of 8.6, a probability rating of 0.83 to generate an overall risk score of 7.1. A response risk strategy is the client will need to allow for additional time to carry out the works at a smaller cost. A 7-day program to complete the project will be very costly and likely cause the program to go over budget. A current impact probability score of 71% has generated a risk contingency amount of just over $57,000.